Okay, so welcome to the sixth design pattern and framework session. So today we are going into the fifth design pattern, which is the proxy design pattern. Right. So if you can remember, we have been discussing design patterns in three categories. One is creational, the structural and behavioral. Until up to now, we have discussed two types of creational design patterns, factory and singleton. And then we have discussed adapter and facade design pattern under structural. So today we are going to discuss another design pattern that comes under structural, which is proxy design pattern. Now, before we move into the discussion, just want to give you a heads up. We will be discussing a couple of OOP concepts. One is interfaces and the other one is polymerism. Right. So before we move into design pattern, I'm pretty much sure you are familiar with the word proxy. In terms of networking, you may have learned about uh, something called proxy server. So what's a proxy server? Again, I'm not expert in networking. So this is a very simple architecture of a proxy server. So idea of a proxy server is it's a intermediary between a user device and the server. Key functions of this proxy server is it hides a client's IP address from the server, and it can block or allow the content to the users, to the clients, and it can cache it has a caching mechanism as well. It can handle security, and it can bypass restrictions as well, depending on few rules. So if you look at the flow of this environment, you would say client is calling the destination server, but it goes through the proxy server. And when the destination server replies back, it goes through to the client through the proxy server. So that's a high level understanding of proxy server. Now, when it comes to design pattern, it uses a similar architecture. So if you look at proxies, these are other proxies that we use in day-to-day life. If you look at credit cards, they are proxies for money. Instead of money, you use credit cards. And to represent people, there will be representatives. Again, they are proxies. And if you look at the middle picture, those are when you want to test the car crashes, you can't send actual people. Instead, you are sending proxies inside the car to understand severity of the car crash of a car. So these are the proxies that we see in our day-to-day life. So what's a proxy design pattern? So proxy design pattern provides a substitute for another object, and it controls access to that object, allowing you to perform something before or after request reaches the original object. So you have the original object, you want to send a request, you are sending it through the proxy server. It has some control over the original object. In most of the cases, proxy has the business rule. You implement your business rule through the proxy object. So sometimes it might be the lighter version of your original object. And proxies should be able to accomplish similar tasks as your original object. And sometimes proxies may not be able to perform all the tasks. So in that type of situation, it will delegate its task to the original or the real object. Right. So what are the common scenarios. We have virtual proxy, protection proxies, and remote proxies. When it comes to virtual proxies, they are due to resource incentive operations such as in gaming, image editing, where you need high resources, right? Rather than loading the entire resource, you load the requested the requested or intermediate data. Now, another classic example is lazy loading. You may have heard it. If you go to some websites, you may see it doesn't load the entire page. It will load some sort of information. As and when you scroll down, it will load the next level. Just imagine if you are looking at so this classical example is if you are a cricket fan, go to the Quick Info website during a match. It doesn't load the entire match details. Let's say you are at the 50th over, it doesn't load all the details of the entire match. When you scroll down only, it will load the rest of the details as and when needed. But in your original server, you have all the data. You have all the information. Depending on your request, you will be getting this data through the proxy server. Protection proxy. Authorization of different roles. Remember, we discussed security during our previous semester. In the previous semester, we discussed security mainly in two layers: authentication and authorization. Authentication is verifying the user who is claiming to be. Now, authorization is providing the necessary roles, necessary data level access to the authenticated user. Typically, this will done through the proxy, done to a proxy object. When you are working remotely, you don't get all the resources at once. Instead, you will get few resources as and when needed. Those are the classical examples for proxy design patterns. The important rule is proxy class should have the same methods as the real class. So when it comes to a proxy, you should have the same methods as a real class. Now, how do you make sure that proxy and the real class, both classes have the same objects? What is the OOP concept that you can use? So as I said at the start, we will be using two concepts. One is interfaces and the other one is polymerism. So you will be using interfaces. If you remember, it's a template for the class. So what we can do is we can create a template as a template for the both classes. So make sure that both classes will have the proxy class should have the same methods as the real class. Look at this example. This example is taken from the Coursera course, as I said before. So what happens here is you can see there is a proxy class and then you have the real class as well. So this is the interface. These two classes are implements through the subject interface. So if you remember, when you are implementing through a interface, you have to do the implementation of methods in the concrete classes, which is proxy and real subject. Proxy and real subject. So now when client interact with the interface, it goes to the proxy, and if needed, it will delegate the actions to the real subject class. So this is a high level overview of the proxy design pattern. So same thing. Now, what are the conclusions can be drawn about the proxy design pattern based on its structure as shown in this UML class diagram? Same the diagram as I showed before. Now, there are four options. Proxy and real subject are subtype of subject, sorry. The proxy design pattern achieves polymerism through the implementing a subject interface. The real subject classes knows about the proxy class, meaning that the real class has the attribute that refers to an instance of a proxy class. Proxy design pattern cannot achieve polymerism because the proxy and the real subject classes both are implementing the subject. Now, by going through this, you can easily disregard the fourth one because we said that polymerism will be used in the proxy design pattern. So we can eliminate this one. So if you look at the first one, proxy and real subject are subtype of the subject. Yes, they are subtype of the subject. They are implementing through the subject interface. The proxy design pattern achieves polymerism through the implementing a subject interface. If you go back to this design, what happens is it can do, if you go back to the polymerism discussion, what it happens is same object will act differently. So you can see how the polymerism is being implemented through the proxy design pattern. So in this one, third one, real subject class knows about the proxy class. No, real subject doesn't know about the proxy class. It happens other way around. What happens is proxy class delegates its actions to the real subject. So these are the correct answers. So basically first and second answers are correct, whereas 3 and 4 are wrong. Right. So let's look at a practical application on proxy design pattern. So let's take a scenario, retail store with global distribution in and warehousing. So let's take this hypothetical scenario where orders may be routed to the warehouse without stock. Okay, so scenario is this. You have multiple warehouses and you get the orders from customers. So as a customer, you might be ordering multiple items with different quantities. Now, you have multiple stores. In one store, one warehouse can may be able to fulfill only one item. Think if you are a customer, what will happen? If you are a customer, you have to go through all the warehouses and verify whether the stock is available. So it's a hassle for the customer. Rather than doing that, what happens with the proxy design pattern is we will make sure the client will call to the proxy class. Proxy class will delegate the action to all the relevant warehouses. So for the customer, it's a one call to the proxy class, and proxy class will delegate his task to the relevant warehouses. So it's simple like this. So client will call the proxy class. Proxy class will go through the multiple warehouses and verify which warehouse can deliver which item in what quantities. Right. So this is the implementation. So if you recall your interface knowledge, this is an interface. I order. Typically for interfaces, we start with a capital I. So it goes as I order, and it has a method called fulfill order. So remember, in interfaces, you will have only the signature, not the concrete method will not be available in interfaces. So you have an order fulfillment proxy class, and then you have the warehouse real class or real subject. Now what happens here is you have the list of warehouses in the proxy class as well as the fulfill order method. So in the warehouse, these are for each warehouse you have there will be object from this class. So you will have fulfill order at the warehouse level, and you have additional implementation of current inventory. So client doesn't need to know where the items are, which warehouse contains what item. He doesn't need to know about those things. He will simply call the order fulfillment class. Right. So let's see how the implementation is. So this is the design, there's a subject interface. So it's an interface. So as you know, interface, we implement only the signature only, no return types. Return types is void. And then you implement the real subject class. So in this case, if you recall the case, real subject class is warehouse class, where you have the stock items, where you have the current stock level and everything. So here you will have the two items. You will have the stock items and available stocks, and you will have when there is a fulfillment, you get the order items, item list, and you get the relevant stock item. So this is where the proxy class is the little complex here. So so you have the fulfill order, which get the order object, and here you can see two iterations. Here you can see two iterations. One is item, another one is for warehouse. Now remember, when customer is sending his request, he is saying, I need this item in this quantities. Item A, quantity 5. Item B, quantity 2. Item 3, item C, quantity 4. So what you do there now is, you go through the, let me quickly share this in a whiteboard. So what happens here is, customer order will look like this. Item A, he needs 5 items. Item B, he needs 6 items. Item C, he needs 10 items. This is his order. Now, in the proxy class, what it does is, it will take the first item and iterate through all the warehouses. Let's say we have multiple warehouses. Warehouse 1, warehouse 2, warehouse 3, warehouse 4. So what the proxy class does is, it will select the first one and check the stock count. Check the stock count. Check the stock count. If it get the correct stock count, it will return here saying that it will have a WH4. Item A will be delivered from W warehouse 4. So similarly, it will go through all the items one by one. Iterate through all the item list. Right? So that is what these multiple iterations are. Now remember, this can be a little complicated. Why? There can be scenario where you're not just selecting a warehouse. It depends on the customer's proximity as well. Now, for example, if I relate this to Sri Lankan context, if the customer is in Colombo, and just imagine if you have a warehouse is in somewhere in Anuradhapura. Of course, you have the relevant item, but that will take long time to deliver. And other conditions also you can take into consideration. So you can see here in the proxy class, you implement a business logic as well. You implement the business logic in the proxy class. Right. What are the other usage? We have discussed this sort of a summary. Protect the real subject class. So subject class will not be exposed to the client. It's going through the business logic that were implemented at the proxy level, proxy class. And because of the fact that it is a polymerism, to make polymerism, we need to have same methods in both classes. And another thing, lazy loading is mostly used through the proxy class, where whenever you want the actual data. Until you need that data, you will access the proxy class, and your original data will be in the real class. So in case of a need, that request can be delegate to the real class. So these are the other usage cases we discussed. So you can go through them and understand them one by one. Right. So let's go through this example as well. Another couple of examples. So if you look at this one, we have an interface, internet interface. It has a method, rather method called connect to, and with the string is host string is coming here, which is the host string, and then you have the real internet class, which has the which connects to the given host. So that's a real class. Now you can see the proxy class. It's again implements from the internet class. So there you can see some business logic. What it does is you have a list of banned items, banned list. So when the customer request, you can see it comes to the internet class. Internet object will be initiated from the proxy internet. So this is a classical polymerism implementation that we discuss in the level 1, right? So you can see, so then what happens? So internet.connect Google, it will go through this list, and you can see if it is banned list. So if this item is available in the list of these strings, it will not be connected. If not, it will connect to the site open will be connection will be open to this particular host. So you can see how polymerism was implemented. Polymerism was implemented in proxy design pattern. Right. So we have another example. So you can see video downloader. So I have video downloader, and you have so you download this video. So you can see it's nothing. If you want this website, it will be download, right? It will download from this class. So this is not proxy. This is you are directly connecting to, you can see here, you are directly connecting to the real video load. And then what happens? This is your proxy class. This is your proxy class where you will have the caching will be implemented in this proxy class. You can see the caching also implemented in this proxy class. So if it is available, proxy class will return the value. If not, it will delegate the method to the real class. So these are the real world scenarios. Remember, we discussed few real world scenarios. Image viewer apps, right, where load image on demand, which is a virtual proxy. Some distributed systems like cloud storage, they use a proxy, remote proxy. Protection proxy, where the banking systems control access to transactions. Enterprise apps, right, when you are looking at the ERPs, they will have the protection proxies. So these are the other examples for proxy design pattern. You can go through them and learn more, self-study other design, other use cases. So I have few questions for you when you're coming for the lecture, right? Please answer these questions and come so that we can discuss. So why it is important that both proxy and real subject implement the same interface in the proxy design pattern? What is the reason? How does the design pattern improve flexibility and security when interacting with the real objects? In what scenarios might using a proxy add unnecessary overhead instead of a benefits? When you are looking at design patterns, it is very important to look at their cons as well. We are looking at the positive side of this, but there are negative side to these design patterns as well. So when we are looking at those things, we need to look at what are the negative side of those as well, so that it should not complicate your code, right? So let's discuss those things during the class. Hope you will go through this note and go through this lecture, this particular lecture, and come with be prepared for our next one. Thank you very much.